Thank you for watching this video. I would like to go over the answers to this naming worksheet video. I'm going to go ahead and jump right in. Hopefully the video won't take too long, but hopefully it should answer any questions that you may actually have about the video. So I'm going to start with question number 1. The first thing that I want to make mention is what you actually are going to have to be solving for in this first part. This first part says name or write the formula for the following binary molecular compounds. This is important because of one thing. When it says molecular, I need you to think covalent. And whenever we have covalent compounds, the next thing I need you to think of is that we have prefixes going on. And so whenever we have prefixes, these are going to be the easiest kinds for us to do. So because it tells us it is a molecular compounds, these should be very, very easy. Now, let's pretend that you did not see this binary molecular compound. What I would also need you to recognize is the first 3 is that when you look at these formulas, you can automatically tell without a shadow of a doubt that they are going to be covalent bonds. That's going to be something that you should already know how to do from previous taught lectures, and so that's very important. And also in the second part, when you see the prefixes, these are going to be very, very easy to do. Because when you see a prefix, you name what you see. Okay, so that's very important to what this entire section right here is going to be about. Okay, so let me erase this part right here so we can get going. And I'm going to hopefully be able to answer any questions that you may have about any of these. So let's zoom in and let's go ahead and get started. So the first one, again, like I said, we're going to have to be doing prefixes. If you are using the flow chart that I have provided or you don't have access to the flow chart, hopefully a lot of these are going to make sense anyways. But remember, we're going to have prefixes on these. And if it's a covalent bond, the first element will only have a prefix if the subscript for that element is more than 1. And in this case, the first subscript is going to be the subscript is 4, so it's going to have a prefix. So the first one is going to be tetra, because tetra goes along with 4. And also, now we need to understand how to write the part of the name. Since sulfur is written first, it's going to keep its name. You're just going to add the prefix. So it is tetra sulfur. Okay, now the second element is going to be a lot different. The second element will always change. There will always be a prefix, and the ending will always change. Well, we know that the prefix has to be di, because di is going to go along with the subscript 2. And so I'm going to have di, and the nitrogen is going to turn from di-nitrogen to di-nitride. Okay, and so that is the answer for that one, tetrasulfur dinitride. I know it doesn't sound right, but again, some of these you just kind of have to play with. And let me just forewarn you, some of these may not even be real actual compounds, but the naming system is the important aspect here. Okay, moving on to the second one. Boron is the element. There is no subscript, so that tells us that we don't have to have a prefix on the first one, and so it's just boron. The second element will always have a prefix, and the ending is going to change, and the prefix for 3 is going to be tri, and so it's going to turn from iodine to iodide, so tri-iodide. Now, I know one thing is going to kind of, let me write this again. One thing is going to kind of look a little weird is because I have 2 I's side by side. What you've got to remember is that tri gets to keep the TRI, and iodide must keep its name. So, yes, there is a need for the double I's right there, okay? I know it looks weird, but there is a necessity for that, okay? Moving on to the next one. We know that there is a need for a prefix on the first element. I want you to think. I'm going to ask why. Why does the first one need a prefix? If your answer was because the subscript is more than 1, you are correct. And so it's going to be di-phosphorus. Okay? And the second one will always change. It's always going to have a prefix, and it's going to end in I. And so we need to know now what the prefix for 5 is. And if you think about it, I always like to think about the military building in Washington, D.C., and hopefully you know what that shape is. I'm sorry it's so bad looking, but that is the Pentagon. And so prefix for 5 is penta. So it's going to be pent oxide. And I'll explain the double vowel situation later. Hopefully you already understand what I mean by the double vowel situation. You are allowed to drop the A in this case. All right, so moving on to the next type. I like to say pray for prefixes because it really just makes things a lot easier to understand because these are way too easy to mess up. If you see prefixes, please just write what you see. And so we have antimony tribromide. Well, I know that there's no prefix on antimony, so I know it's just going to be SB. And I know that bromine turns to bromide, so it's going to be BR. And then tri tells me that there are 3 of these things. So SRB3. Let me give you something that's going to be wrong because I see a lot of students do this all the time. They want to do this. They want to do SB3BR. What they want to do is they want to take the tri and they want to attach it to the first thing. Well, that should not even make sense because the reason why is because if you think about it, this tri is attached to bromide. So that subscript must go along with it. Okay, so again, hopefully that should make a little bit of sense right there. All right, so now let's do the next one. The next one is diphosphorus. Well, P, it must have a 2 because of the di, it's attached to it. And then tetroxide, so you see how the double A's have been left alone, just like we did up here in pentoxide. We dropped the A from pentaoxide to just pentoxide. So again, it's the whole double vowel thing. And remember that tetra goes along with 4, and so P2O4 is your formula. And then finally, the last one is tetranitrogen. So we're going to have N4 dioxide is O2. Okay, and so these are your 3 answers. And like I said, some of these may not be real, but the naming system is the important aspect here. Okay, all right, so let's slide up, and now I'm going to kind of zoom out for just a second, and so let's look at something a little bit different here, because this time, the next group is ionic, and the big thing I want you to write here is no prefixes. We're not going to have any prefixes here. Okay, so that's number 1, and number 2 is our transition metals need Roman numerals. Okay, our transition metals need Roman numerals. Now there are 3 exceptions to that. That is silver, zinc, and cadmium. And again, hopefully you've already understand this, but the reason they do not need Roman numerals is because they're always those charges, and the reason we have Roman numerals is because transition metals have the ability to transition, which means they have the ability to change. So you have to indicate exactly which charge it is, okay? All right, so let's kind of jump right into these. Hopefully this will make a little bit of sense. All right, so we have barium fluoride. All right, so barium, I know that barium is in group 2, so it's going to have a charge of 2+. Fluoride, you eyed by yourself, so it's just going to be F. Now fluorine is in group 17, so it's 1 negative. And so when I crisscross, I'm going to get BaF2. And that is my final answer. Okay, calcium nitride, all right, calcium, I know calcium is a metal. It's in group 2, so it's a 2+. Nitride, you eyed by yourself, so it's going to be N. Nitrogen is in group 15, so it's a 3. Excuse me, let me fix that. It is a 3-, and so this time when I crisscross, I'm going to get a little bit something different. I'm going to get Ca3N2, and that is my final answer. All right, aluminum oxide. Aluminum is in group 13, so aluminum is going to be 3+. Oxide, so it's oxygen by itself. It's 2 negative because it's in group 16. And so when I crisscross, again, I'm going to get a little bit something different. I'm going to get Al2O3. And that is going to be my answer for that one. All right, so now let's go to the next part, naming these things. Again, I've already told you there are going to be no prefixes in this. Excuse me, wow, okay. There's going to be no prefixes, and if it's a transition metal, it's going to need a Roman numeral. So whenever we come back down to this one, I have students every year that mess this up because they want to put dilithium. Why can you not have dilithium in this particular answer? If you said because lithium is a metal and there's no prefixes on metals, then you're right. That's the exact reason we have to have that, okay? All right, so I know that it's just going to be lithium, and I know what you're going to think, well, where did that 2 come from? Now, I'm going to show you in just a second. And so the reason you don't have to talk about it is because, remember, if we have Li2O, where did that come from? Well, how did I get the subscripts? Remember, the subscripts came from reverse crisscrossing, right? All right, so really what we initially had was Li plus and O2 minus. Well, that's where it came from. Well, we know lithium is a group 1, so we don't have to give it a Roman numeral. We know oxygen's a 2 negative, and that's just how the naming system will work. You don't have to include the 2 in there because it's understood of how the charges crisscross. Okay, the second element is alone, so it's going to end in "ide," and it is oxygen, so it just turns into lithium oxide. Okay, so that's that one. Also, we move on to the next one. Now, here's one of our examples we just gave just a minute ago. If you look at your periodic table, we know that silver is a transition metal. We know that, okay? However, it is one of our few exceptions that we have to deal with that does not need a Roman numeral. Again, the reason why it does not need a Roman numeral is because it will always be silver 1 plus. That's just what it's always going to be. And so we have silver iodide. Now, again, the reason it's iodide is because iodine was by itself. All right, and then the last one, we're going to have sodium. And then fluorine is going to turn into fluoride. That is the answer for that one. Okay, moving on to the next group. Now, this next group is also going to be ionic bonds. However, if you'll notice, these get a little bit more complicated. And this is where you're really going to have to pay attention to your polyatomics, because if you don't know your polyatomics, by the time we get to this, you're really going to struggle through this. This is really going to kind of mess you up, okay? All right, so let's look at the first one. We know the first word is magnesium, okay? We do not need a Roman numeral because magnesium is not a transition metal. Okay, and then we have the second element is not alone. It is paired up with oxygen, and specifically it's paired up with 4 oxygens. So that's going to tell you your polyatomic. And if you know your polyatomics like you should, then you should know that SO4 is sulfate. So this is magnesium sulfate. Okay, the second one, some of you will not know SO2, and the reason you don't know SO2 is because it's not on your polyatomic sheet. I will forewarn you, I will never test you on something you don't know the polyatomic for. So I'm just going to kind of give you the answer to this one. We know that, excuse me, I did not mean to write in. We know that Na is sodium. And again, the reason we don't need disodium is because these are ionic. We don't need prefixes, nor do we need sodium 2 because it's in group 1, so we don't need a transition metal. Roman numeral, excuse me, with that. And again, like I said, this is a polyatomic you do not know, and it is sulfite. It is sodium hyposulfite. Okay? This next one, I know this looks really weird because what you're going to do is you're going to want to look for an N, you're going to want to look for an H, and you're just not going to be able to figure all this out. But again, this is where your polyatomics really come into play. You've just got to recognize that NH4 is a group, and you've got to realize that ClO3 is a group. And so when you know that, you can recognize that NH4 is ammonium. And again, the only one I've asked you guys to memorize that's any different is NH3. And this is ammonia. It ends in IA versus IUM, okay? All right, and then continuing to answer this one at the top, it is ammonium, and then ClO3, hopefully you recognize that as chlorate. So ammonium chlorate, okay? All right, so let me kind of erase some of these things so we can kind of get back to the same page here. All right, so moving on to the next one, Mg, and then what is that thing? And again, C2H3O2. I know it's a big polyatomic, but you should know at this point. And so we should have magnesium again. And again, the reason we don't have a Roman numeral is because magnesium's in group 2. It's not a transition metal. And then you should also know that C2H3O2 is acetate. So this is magnesium acetate. All right, the next one, we've already kind of done an H4. So this is ammonium again. Ammonium, and then IO3 is iodate. And to be quite honest with you, I don't have the polyatomic sheet in front of me. I'm not sure if it's on there or not. But again, like I told you with a hyposulfite, I will never test you on one that you do not know or you've never been shown before. But that one is ammonium iodate. All right, the next one. We know that it is silver, and again, it's like I've told you, silver is a transition metal, but we do not need a Roman numeral because silver will always be that exact charge, okay? And so it's always going to be silver 1, so we don't have to include it. So it is silver, and it's paired up with NO3, and hopefully you recognize that as silver nitrate, okay? Moving down to the next groupings. Got several here, so now we're going to kind of flip it a little bit. So magnesium hydroxide. All right, so now we got to really know what we're doing, all right? So magnesium hydroxide. So we have Mg, and I know that magnesium is in group 2, so it's a 2+. Now, what do we put our polyatomics in? Hopefully you should know we put our polyatomics in parentheses. So it's MgOH, and then it's MgOH minus on the outside. And again, you crisscross. But remember, the charge value will go on the outside of the parentheses to protect. And so it's going to turn to MgOH2. And that's the final answer for that one. Okay, potassium phosphate. You have K plus PO4 in parentheses with a charge value on the outside, and it's PO4 3 negative. And so when you crisscross, you get K3PO4. Now, know what some of you are going to ask? Well, wait a minute. Where did your parentheses go? Why did you drop those? This is on your flowchart. If you'll notice and look, anytime that the subscript that's going to show up behind the parentheses, if it is a 1, you can drop them. You don't have to have them. Again, so it's just letting you know it's the correct way to do it. All right, calcium nitrate. I know calcium is in group 2, so I have Ca2+. I have nitrate, which is NO3 parentheses minus. And again, so when I crisscross, I'm going to get CaNO3 2. This is a big one, guys, because the reason why, what I do not want you doing is dropping the parentheses in this case, which would look like this. CaNO3 2, and it looking like 32, which doesn't make sense. Or this is the absolute wrong thing to do, is CaNO6. Do not ever multiply those because, again, nitrate's name must go with its formula, and the formula is NO3. You can't change it when it says specifically nitrate. You must keep the NO3 together. Okay? All right, so let me erase this so we can move on to the next grouping. Okay, all right, so we've got barium hydroxide. Barium is Ba. I know it's in 2+, because it's in group 2. Hydroxide is BaOH minus. All right, so then we've got the answer of BaOH2. Okay, once you crisscross. Sodium sulfite. This is a good one, sulfite. All right, so I have Na+, because sodium is in group 1. Sulfite is SO3, 2 negative. And when you crisscross, you're going to get Na2SO3. And that is going to be your final answer there. Potassium perchromate. Again, perchromate you've never seen before. And to be honest with you, I'm going to actually have to think about what it is. It's very rare to have. Potassium perchromate. Potassium's in group 1, so it's a +1. Chromate is CrO4, 2 negative. So perchromate means 1 more oxygen. So it's CrO5, 2 negative. And so when you crisscross, you're going to get K2CrO5. And so that's going to be the final answer. And then the last one on the front page is going to be lithium sulfate, which is Li+. Sulfate is SO4, 2 negative. And so when you crisscross, it's Li2SO4. And that is the final answer for that one. All right, we're about 20 minutes into this little video, and so let's go ahead and let's finish this up. These next are going to be a little bit more difficult because all of these are going to be your transition metals, which means you're going to have to know how to reverse crisscross and know how to check your charge on the anion. This video is not necessarily going to be for teaching purposes. It's more of, do you have the correct answer? Okay, and so we need to be able to fix that. And so I'm not going to spend a whole lot of time explaining. I'm just going to run through and make sure that you have the answers correct with a little bit of explaining as I go. All right, so looking at A, I know that it's going to be iron, but again, this is a transition metal, so I know that I need a Roman numeral in here. Well, here's the issue with this one. This is the first one that comes up, and there's going to be several of these like this. As a matter of fact, the first few are this way. When I reverse crisscross, I'm going to get iron plus, and I'm going to get sulfide 1 negative. There's a huge issue here is because, remember, we always have to check the charge on the anion. Well, I know that that is wrong, so I need to multiply the entire thing by 2, so I get Fe2 plus and S2 minus. Now it is correct. So, and again, the thing about it is my Roman numeral is the charge on my metal, and so it's going to be iron 2. S is by itself, so it's going to end in I, so iron 2 sulfide. Okay. The next one, we have cobalt. Cobalt. Again, the same exact thing happened this time as it did with the previous problem. When I pull back, I get CO1 plus. Remember, it's 1 plus that you're pulling back. You're not pulling back that 3 because that 3 really belongs to carbonate. And so it's going to be CO3 1 minus. This is wrong because CO carbonate is supposed to be 2 negative. So you're really going to get 2 plus and 2 minus when you multiply by 2. So again, it is cobalt 2 carbonate. Okay, same exact issue with C. I'm going to erase some of this over here to the side. The same exact issue come up, and I'm glad these first few were this way. Again, the issue is when you reverse crisscross, the charge on your anion is incorrect, and you must fix it before you actually give it the Roman numeral. Okay, so we know it's copper. And if you reverse crisscross, it's going to pull back a 1 plus and a 1 positive. Remember, you're not pulling the 4 because that 4 belongs to sulfate. Okay, so there's really an understood 1 back there. When you pull it back, you'll get a 1 and a 1. It's supposed to be a 2 negative, so we multiply the entire thing by 2. So we're going to get copper 2 sulfate. Okay, all right, now this one actually is going to work. It's going to be 10. And when you reverse crisscross, you get a 4 plus and a 1 minus. The 1 minus on the bromide, so let me just show you. SNBr, you're going to get a 4 plus and a 1 minus. This 1 minus is correct for bromides, which means the 4 plus is correct. So it is 10 for bromide. I'm going to be honest with you, I'm skipping E because I don't like mercury compounds. The next one is lead. This one is just like A, identical to A, and so it's going to be lead 2 sulfide. Okay, the next one, manganese. Just like we've had other issues with. Okay, so notice what happens when we pull back. We get Mn2 plus, O1 minus. What's wrong with that? Oxygen is supposed to be a 2 minus, so that means I need a 4 plus for manganese. So it is manganese 4, oxygen's by itself, and so it is manganese 4 oxide. Okay, let me erase this. And again, I know I'm running through this really fast. This video is not for teaching purposes. This video is for making sure that your answers are correct. Okay, the last one, we know that Au is gold, so gold. When I reverse crisscross, I'm going to get a 3 plus and a 1 negative for nitrate, which is correct. So that means my 3 is correct for gold. So it's gold 3 nitrate. All right, we have another one. We're going to have 10. So 10. When I reverse crisscross, I'm going to get a 4 plus and a 1 minus, which is correct for hydroxide. So that 4 is correct for my 10, and so it's 10 for hydroxide. Okay, these, I'm telling you now, those that we just did are the hardest of all of naming compounds, making sure that your anions are correct. And if they're not, what do you do to make sure that they're changing? Every year, students forget to check the charge on the anions. So the only thing that I can do is hammer in terms of practicing, making sure that you understand all of those things, okay? All right, these next ones are going to be pretty simple. These are a lot easier. I personally feel that taking the names and going to the formula is the easiest part to me, okay? All right, tungsten 3 oxide. Remember, all these Roman numerals, they're going to go to the metals, not the anion part, okay? So tungsten is W, and it's 3 plus. Oxide, it ides by itself, so O2 minus. And so when I crisscross, I'm going to get W2 SO3. Nickel 3 sulfite, so I have Ni3+. Remember, sulfite is SO3, 2 negative. Come on, Mr. Pen. 2 negative. So I got to get Ni2, S in parentheses, SO3 in parentheses, 3. SO3, 3, and that's the final answer there. Mercury 1, get rid of it. We don't want to do mercury compounds. Copper 2 phosphate, all right, so Cu2+. Phosphate is PO4, 3 minus. And so when I crisscross, I get Cu3, PO4, 2. That's the final answer there. Bismuth 3 iodate, so we have Bi 3+, and iodate is IO3 minus. And again, I don't think you have iodate. Like I said, I cannot remember specifically, but I'll never test you on one you don't know. But in this case, it is going to be Bi IO3 3. And then finally, one more to go. Lead 2 chromate. So we've got, L. We've got Pb2+. Chromate is CrO4, 2 minus. And so the charges will cancel. Good. And so we have PbCrO4. And then copper 1 iodide is Cu+. Iodide, so it ends in I, so it's I by itself. Iodide is in group 17, so it's -1. And so again, our charges cancel, leaving us with Cui. All right, last little bit. I'm going to run through these probably faster than that one, just because the acids part, I don't want to take a whole lot of time. Again, this whole video is just making sure that you got the correct answer. Nitric acid. Ic came from 8, so this was the nitrate formula. And so there's no hydro, so there is an O, and so it's HNO3. Hydro, so that tells me there's no O. So it's fluoric, so it's HF. Hydro tells me there's no O, so it's HBr. Chloric, ic came from the 8 polyatomic, and so it's ClO3. Acetic acid is HC2H3O2. Carbonic. Now, this is a good one. All right, so we know that there's an H in front of all of them. It came from 8, so I know it's carbonate. But remember, this is a little different. So it's H+, CO3, 2 negative. Well, you still have to crisscross these ions just like you do anything else. I know I didn't do that any of them before, but they were all 1 plus and 1 minus. But this case, it's not. So it's H2CO3. And this is just extra bonus information we'll learn later. This is what we call a diprotic acid. And that should kind of make sense. Protic means proton. Di, of course, means 2, and so we have 2 protons. And I'll explain the protic part later. All right, finally, hydro. That tells me there's no O, and so it's just HCl. Okay? All right, and the last grouping, we have there's no O, but it's still a polyatomic, and so it's cyanic acid. I'm going to stop writing acid after this. All right, there is no O, so it's hydro phosphoric. Phosphoric. That's a weird one. I've never hardly seen that one. All right, there is an O, and so this is sulfate. 8 turns to ic or ric in some cases, and so this is sulfuric. Sulfuric acid. There's no O, so this is hydrochloric. There's no O, so it is hydrosulfuric. And notice the difference here. These two right here are very, very similar, but the major difference is the hydro. Okay, there's no O there, so that's why it's the hydro. All right, there is an O here, so we don't need hydro. That's phosphate, and 8 turns to ic or ric because I ate with ric, so it's phosphoric. And then finally, there's no O, and so it's hydroiodic. Okay? All right, so hopefully that was a help, and that is the end of this session.